Welcome to TinyML, or Tiny Machine Learning. This course is like no other class you've probably taken yet, as it is at the absolute bleeding edge of technology and machine learning. You've all probably heard about the buzz about machine learning, and that's why you're here. This is a very exciting course that first introduces you to the fundamentals of machine learning, where you'll develop applications to process and understand images, speech, and motion gestures, all on battery-operated embedded hardware that costs less than $1. This enables interactive and useful sensor-based systems to solve real-world problems. Think of this as the first course in both machine learning and embedded systems. You don't need any background in either. TinyML brings AI into the Internet of Things to create modern applications at the edge of the Internet, right where the action's happening. Such systems can be deployed in agricultural fields to monitor water and nutrition for better yield, can be deployed in forests to detect forest fires early, and can be deployed on endangered animals to safeguard them. And this can be the basis of the next exciting startup, something which you can do after this course. Tiny machine learning, or TinyML, is an emerging field that is at the intersection of machine learning and embedded systems. An embedded system is a computing device that is usually small or tiny, like the one I'm holding in my hand, that operates with very low power, extremely low power, so much so that some of these devices can run for days, weeks, months, sometimes even years on a button cell. TinyML is all about just this, taking these small little computing devices and enabling it with machine learning smarts. Now, what is machine learning? Well, machine learning is a subfield within AI, or artificial intelligence, that uses a lot of data to infer interesting patterns about new data that it's seeing. Together, the intersection of embedded systems and machine learning is going to unlock a whole new world that is the world that I'm going to introduce you to in this course. Before we go on, let me introduce myself. I'm Rahul Mangharam, a faculty member from both electrical and systems engineering and computer science. I live at this intersection between hardware and software, between algorithms and processing. And I work on life-critical systems like self-driving cars, implantable medical devices, and intelligent energy systems for buildings. Basically, where machine learning runs in devices which make life and death decisions on our behalf. My lab works on building safe autonomous systems, where we build tools to ensure these intelligent machines cause us no harm under all possible operating conditions. And I'm very excited to be teaching you everything I know about this cutting edge field. How many of you have ever said, "Hey Siri," or "Okay Google," or "Alexa"? I'm sure nearly every single one of you has said these words. Have you ever wondered what happens when you speak those words? What does the machine know, to wake up and address you? Well, there are specialized sensors that pick up the sounds around you and continuously process them, waiting to hear those keywords. In this class, you'll not only understand how such devices work, but you'll also learn to teach the machines to respond to your own keywords. And that's just the tip of the iceberg. Now, the key difference is that while these smart home hubs resemble the application of TinyML, these devices are largely plugged into the wall or they require charging. I'm talking about putting TinyML into these tiny, tiny little processors and then forgetting about them. There's no power being given to them outside of that little battery. And that's the difference between the applications that we're seeing today and where we're going in the future. As part of this course, you'll get this kit, which you will actually develop your machine learning algorithms to run on. Let's talk about some of the more forward-looking examples. Let's talk about autonomous drones. Drones that are completely independent, that operate fully by themselves. Imagine autonomous drones that are able to do video surveillance in order to keep us safe by figuring out what's a threat, what's normal, and so forth. Or they might be able to venture really far out into places where humans cannot go. For instance, later on, we'll talk about how drones are being used in the Amazon forest for preserving our wildlife. So for instance, when the forests are deforested, we can actually go in and autonomously plant new seeds so that we can keep the forest growing. Or we can talk about mobile robots, which are extremely important in the service industry for taking care of the elderly in the future. Well, these mobile robots need to be moving around, constantly sensing the information around them And machine learning is very good at that problem. And we need to be able to pack in lots of sensors into these robots and do that with extreme efficiency so that they can operate on battery power. Or think about smart glasses, right? These are passive in the sense that they don't proactively do anything. But imagine smart glasses in the future. For example, you're in a new country and someone's talking to you in a language you don't know. And your glasses are able to do real-time machine translation and then be able to display that in front of you. These are just some remarkable applications. Or let's talk about TinyML in the medical area. Here, I'm showing you Micra, which is from Medtronic. It's the world's smallest pacemaker that goes into your heart. It's small, it's non-invasive, and it's completely self-contained. And if this device had machine learning in it, it would be able to perhaps proactively tell you how your heart's doing, or be able to do things for you so that you have a better, healthy life choice. Or let's talk about what Elon Musk is doing, right? Whether you love him or hate him, he's always up to something. In his startup Neuralink, engineers and scientists are implanting chips inside the brain so that they can send signals to understand the brain activity. By measuring these signals that are emitted by neurons, we might be able to learn things about our brain. And in doing so, we may be able to cure diseases such as depression, insomnia, or epilepsy. So let's get to a more specific example. Here I'm talking about the Elephant Edge project to protect the dwindling population of these gentle giants. This project uses a smart collar that goes on these elephants that is totally non-intrusive, does no harm to them, but is there constantly sensing interesting signals so that we are able to help them have a better life, a better coexistence with humans. With this collar, rangers can monitor risk from poaching by manually observing the activity, location, and herd movement. But what if we could build machine learning models that could be put into small little devices where if they're able to figure out, for instance, the elephants were moving into a high-risk area and then be able to send real-time notifications to park rangers to keep them safe. The park rangers could react to them and make sure that the elephants go away from that danger zone. Or perhaps we can do human conflict monitoring, where we could build intelligent machine learning models that are able to sense and alert when elephants are heading into an area where, for instance, farmers live, so that they can proactively get out of the way or do something in order to make sure they are safe and the animals are safe. We might be able to do this activity monitoring as long as we run these on the hardware on the elephants. We may be able to learn about things about the animals, such as, are they swimming, drinking water, or sleeping, and so forth. And by learning all these things, we might be able to take better care of them. We might also be able to do communication monitoring. What we mean by that is by sensing sound, we may be able to understand how these animals are actually communicating to each other. But in order to do all of that, we need TinyML. We need to be right there where the data is, where we can capture that information, those sounds, those signals, where all of this is, so that we can do real-time machine learning right at the source. And these are all remarkable applications of TinyML. So what I'm saying is that when you think of TinyML, don't think just about the future. Think about the here and the now, how this technology that is potentially in your hand has the ability to transform the world. Now, how are we going to be able to achieve all of this? Well, this course has 3 parts. Part 1 is all about understanding the language of machine learning. Part 2, we're going to build useful applications with machine learning. And in part 3, we're going to physically deploy machine learning models that we build into these small little devices. And in doing so, you will gain a lot of appreciation for the challenges in enabling this capability. But stick with me. I promise you, by the end of the time that you finish this course, you're going to be very proud of knowing how to program embedded microcontroller devices with these machine learning capabilities. We're going to learn the entire machine learning pipeline, starting with capturing sensor data, building your data sets, constructing neural network models, and training them. We'll do all of this using TensorFlow, which makes it easy to build ML applications. Then we convert these models from running on servers and laptops into running on this embedded hardware. We learn to optimize them for size, speed, and energy so that they can run on microcontrollers and interact with us in real time. Finally, we'll deploy them on real hardware, and you'll learn about using TensorFlow Lite Micro to make that happen. In the first part of this course, you'll learn the fundamentals of TinyML. How do neural networks work, and how can you build them? We will understand the machine learning programming paradigm, where we will train the machine to find and learn patterns in data. And then we will use that to solve problems from simple regression to complex computer vision. The course is structured to give you an overview of TinyML, starting with the applications, which range from keyword spotting, sound recognition, such as breaking of a glass or window, to understanding the technology that enables us to build such fascinating applications using machine learning. You will develop apps to understand speech, detect objects in images, and identify anomalies in sensor data, and learn the skills across the ML lifecycle, from developing data sets, deep neural network models, to application deployment. What this course is not is about theory. It is a hands-on applied machine learning course where you build applications. We'll have a special course kit for you, like the one I have over here, that comes with a bunch of sensors and a microcontroller. Using this, you can do all your coding assignments. The course will ultimately culminate in a course project where you'll demonstrate all that you've learned by navigating a cool robot. We'll learn with both online and offline lectures. Collabs will provide hands-on learning with code in the cloud using Google's collaboratory environment, which will also host your assignments, reducing the need for powerful laptops. More on Collab later on. Assignments will challenge you to take all that you've learned and apply to solve practical hands-on tasks. And these will be done through collabs in part 1 and 2, and will require deploying code to the Arduino microcontroller in course 3. Quizzes act as a knowledge check and will be short and sprinkled through the course to make sure that you are learning the key themes. We will also have lecture notes in the form of readings before every week's lectures. The grades are based on the cumulative activity and learning across the course. This ensures that you have both good conceptual understanding and develop the necessary hands-on skills. Throughout, we will have dozens of tutorials, 5 quizzes, and less than a dozen assignments. Now, you might be wondering what the prerequisites you need. Just basic programming in Python and some exposure to electronics and circuits from your freshman year. Well, will this course be hard? Yes and no. Yes, because the material is hands-on. You'll have to experiment with it. You'll have to try different ways to solve the problem till you figure it out. No, as it won't take more than 10 hours per week. We'll be assisted by your fantastic teaching assistants. Also, this course material has been partially developed by teams in Google and Harvard, and we're very thankful to them so that we can bring you the latest in TinyML in the best possible way. I, for one, truly believe that TinyML has the potential to transform the world that we live in. And in this course, we're going to take you through that journey to uncover the possibilities and learn how to enable those possibilities. Who knows? You might very well be building the next major industry based on TinyML from the lessons that you've learned in this course. So welcome to TinyML, and we're going to have a great time.